the first thing we got to think about before I get too far along is what it means by parallelogram by definition. That's where you want to start with your thinking. What am I looking for if I say I want to prove it's a parallelogram by definition? What's the definition tell me? Two pair of parallel sides. So that means that if I'm looking for a parallelogram by definition, that means I want to have two pair of parallel sides, which means what am I computing? What do I have to calculate to prove two things are parallel? Slopes. Now, the biggest challenge with Chapter 6, when we look at the coordinate geometry proofs, that's what we're actually going to be doing here technically, is doing a proof. Just not the kind of proof we've been doing, is figuring out what your plan is. We will always tell you how we want you to prove it, or if we don't tell you, you can use any of the different conditions out there. So if it had just said, prove it's a parallelogram, you could say, okay, well, let's find the midpoints of the diagonals and see if they match. That would do it. You could say, let's find the length of all four sides and see if the opposite sides match. That'll do it. You could also use the definition, which is two pair of parallel sides, so I'm going to be finding the slopes. My advice is whenever you can, find the slope of the sides. It's the easiest thing to calculate. There's no square roots involved. And it gets most of the work done that we need to get done. Because we can use this for parallelograms, we can use a lot of it for rectangles as well. So it's a good general all-purpose. I don't know what to do, so I'm going to start right in on finding some slopes of the sides. It can sometimes also be useful to map out where the points are roughly. Now, this isn't solving by graphing like you did last year in Algebra 1, where you drew the two lines to see where they'd intersect. You don't have to be that precise, but it is valuable to have a sketch, to have all the big ideas in one place. All right, so negative 3, 2 is going to be around here-ish. Negative 2, 7, that's up here. 2, 4 is here-ish. And 1, negative 1 is right there. So there's my figure, roughly. So it gives me kind of an idea of what I'm looking for. I'm going to need to find the slope of AB, BC, CD, and AD. Knock out those four slopes, see what I get, make sure it all matches. So slopes AB. So AB would be 7 minus 2, negative 2 minus negative 3. Let's see, that's going to give me, that becomes plus, so that becomes 1. Slope is 5. Slope of BC. So that gives me, let's see, 4 minus 7, 2 minus negative 2 is negative 3 over positive 4. That doesn't reduce. Now, the other bit of good news is if we ask you to prove it, then it will work. So you guys can go back and double check to be sure the data you're getting supports the goal. It's like the old rules of proofs. I never would ask you to prove something if you couldn't do it. If it just says, is it a parallelogram, then there's no guarantee that it will work out or not. You're going to actually have to do it and do it right. So the good news is the first couple of assignments tonight are going to just let you, they're going to say prove it. So here's the slope, slope, slope. CD, negative 1 minus 4. 1 minus 2 gives me a negative 5 over negative 1, or a slope of 5. Same, therefore parallel.
Can you slow down a little bit?
Sure. Yeah. Let me knock out this last slope, and then I'll pause for a bit, let you guys get caught up with your writing. And AD. Remember, we're taking the y's. I'll actually write this out the longhand just for those that have forgotten the formula. y2 minus y1, x2 minus x1. So let's see, -1 minus 2, 1 minus -3 gives me -3 over +4. And same, therefore, parallel.
Why was there an AC?
Why didn't I do AC? Well, the thing about AC, that's this guy, right?
So we have to do y segments, not like different combinations.
Right. You do the actual sides. Because if I go around this guy, the slope here is 5, the slope here is 5, and therefore the two lines are parallel. Here I have a slope of -3/4, slope of -3/4, and therefore these are parallel. Haley, what's up?
Wait, so if it's a parallelogram, it has to be these both. Like it has to be. Never mind.
You got it?
I think so.
Okay. Yeah, the thing too here is it says by definition. So that means, I think back, what's the definition of parallelogram again? Definition is two pair parallel sides. Parallel should trigger in your head the find the slopes. Slopes triggers, okay, I've got coordinates. I can calculate stuff. I've done all my calculating. Everybody matches that's supposed to match.
Is it you say by definition what would you do?
Me? I do this way because it's the easiest to do because it's all slopes. But you can do any of the, what do I have, 5 conditions? I'm going to cover this for a second. If it doesn't say by definition, you can technically go after parallels, congruent, take one pair of sides, and just show that length, congruent, and parallel, or find the midpoints. Those, all 4 of those are options if it doesn't say how to do it. But if it does say by definition, or if it says by showing that there is one pair of parallel congruent sides, then that's what you do. And we try not to get you. We try to be pretty clear about what we're expecting. What more can I say about this one in particular? Toss it in the can?
Will you always be able to like draw a sketch so you know which sides to get the slope from?
You should be able to. And sometimes it helps, sometimes it doesn't. As a general rule, we give the vertices sequentially going around the figure, so that kind of helps you a bit. But the sketch can often make sure you don't accidentally find the slope of a diagonal. Since we've got this guy in front of us, let's go ahead and let's prove it is a parallelogram one more time, but use a different method. Just so that we're sure we kind of get the different options out there and to review the formula.